Good afternoon, everyone. My name is Madeus Bolatfe. I'm staff of EdSofta, and today we are going to be running over the next few days. We're going to be running a series of tutorials to help JAMB students for their to prepare for the final stretch. So it's just some sort of preparation as they approach their the JAMB UTME exams. Okay, so for today we are going to be talking of physics. Yeah. So, but before I start, so physics, yes, and then the way we have created this, so there are different sections. So we're taking on a variety of topics, and there are different sections, and then there will be intervals at different sections. So it's not just a full stretch of tutorials. There are going to be intervals at various sections. Okay, so quickly, I would love to introduce you to EdSofta. What is EdSofta? What is EdSofta? Why should I be here? And simply, EdSofta is just EdSofta is a tech company. Basically, EdSofta is a tech company. We specialize in creating solutions to help students do well in exams generally. So JAMB, WAEC, and the likes. But specifically, now we have an app that is out now. It's called EdSofta UTME. It's an app that prepares students for JAMB UTME. It has past questions, study materials, and many other features that help students prepare for exams. So yeah, and that's basically the app we're going to be using for these tutorial sessions. For every time we want to solve questions, this is the app that we will be using to solve questions. And so now if you want to follow along and if you want to like have the app on your phone, you can simply, so we have it on Play Store and we have it downloadable on our website. So we have the Android version, which is on Play Store. Just go to Play Store and search for EdSofta UTME. EdSofta UTME, and then you can install the app. You might need to activate it, but yeah, you might need to activate it to have full access. You need to activate it to have full access to all the features. And then if you want to use it on your system, simply just go to our website at www.edsofta.com. So just go to www.edsofta.com and you would click on downloads. Yeah, click on downloads, and then you will see a variety of our apps, and then you can download for either for your Windows or for your Android. Okay, so having said that, okay. So, and as I said earlier, we will take lectures, solve questions from the EdSofta app, and then take questions from you. Now, scalars and vectors. Now, the first thing we need to talk about is the definition. What is scalar quantity and what is a vector quantity? And simply put, a scalar quantity is a quantity that has only magnitude but no direction. So it only has magnitude but no direction. For example, length. If we're to measure length, we can measure that something is 5 centimeters in length, but there's no direction as to is it 5 centimeters in length northwards or eastwards or northwest or southwest. There's no direction. Or if you're measuring a distance and it takes us the distance between here and here is 5 meters. Is there any in what direction? So when you do not specify a direction, what you have done is you've specified a scalar quantity. So that's why we have examples are length, volume, area, mass, energy, speed. All these things can be defined without a direction. So that's the thing to note for scalar quantities. They have magnitude but no direction. So vectors are the opposite. So vectors have magnitude and they have what? Direction. Vectors have magnitude and they have direction. So examples are displacement. For example, displacement. So sometimes I define displacement as distance with direction, because in the sense that now I'm not just saying that the distance between point A and point B is 5 meters. What I'm now saying is the distance between point A and point B is 5 meters in the northwest direction or in the southwest direction. So by adding a little bit of direction, we've converted the scalar quantity to what? To a vector quantity. So that's why I say this displacement is just simply distance with direction. Same thing goes for velocity. We all know the definition of velocity. Change the distance over time. So now speed is change the distance over time, but the difference between speed and velocity is I have now attached direction. So the velocity is 5 meters per second towards this direction, or at an angle of 60 degrees towards this direction. Yeah, so same thing goes for acceleration and momentum. So basically, that's what scalar and vector quantities are. So now, as you can look at this, say when vectors are directed at angles, the vectors can be resolved into two components. So now, we can just simply we can have something like this. We can have something like this. Sorry, just give me we can have something. So we can have a straight line, yeah. So maybe pointing in the northward direction or pointing in the eastward direction or in the westward or in the southward direction. So those are the four cardinal points. So they are just straight. But now, when you now have vectors pointing at the northwest, so not really not really at the west, but somewhere in the middle, it might be more towards the right or more towards the left, but just in between north and west. So we can resolve. So when you have vectors in that moving in that direction, so yeah, they're in between north and west. So we can resolve vectors like this into two components. We always say that they have two components. So they have the north component and the west component. So, but generally speaking, when your vector is tilted at an angle, so when your vector is at an angle that is not 90 degrees, so this can be 30, 50, any angle. Once your vector is tilted at a particular angle that is not 90 degrees, that is not perpendicular. So what happens is that we can now resolve that same vector into two components. So we normally say the horizontal component and the vertical component. The horizontal component and the vertical component. So as you can see in this example here, we have the northwest vectors and the northwest vector, which is pointing this way, has now been resolved into the northward vector. It's just a sum of the northward vector and the westward parts, as you can see for the diagram. Same thing goes for this other guy. It says an upward and rightward vector, which would have been somewhere northeast. But we have now resolved it into in an upward vector and a rightward vector. So what I'm trying to say here is that once you have a vector that is tilted at an angle that is not 90 degrees, we have a vector that is tilted at an angle that is not 90 degrees, you can resolve that vector into two components. You can resolve that vector into two components. Okay, so moving on. So now there are two methods of resolving vectors. There are two methods of vector resolution. So we have the parallelogram method and we have the trigonometric method. The parallelogram method and we have the trigonometric method. So now, the trigonometric method. So now the parallelogram method, I'm just going to quickly speak on the parallelogram method. So now the parallelogram method, right? The parallelogram method is just what we are doing here is this. It's not really used per se because of the fact of how hard it can be to use. It's not really used some of the time. So I'm just going to switch to a whiteboard. I'm coming. Let me see if I can find. So I'm just going to switch to a whiteboard and okay, so that I can describe what I'm actually trying to do here. Okay, so for example now, if we were to use a parallelogram, if we're using a parallelogram method, the reason why a parallelogram method is not commonly used most of the time is because now to use a parallelogram method, you have to resolve the vectors, you have to draw them using the particular length. For example, if I were to draw, so if I was drawing, so if I had a vector somewhat like this, and then this vector has a magnitude of 5, okay, and then so now if I were to resolve this, what I would have to draw this using the parallelogram method, then draw the same exact length here, draw the same exact length here, draw the same exact length here, so on and so. So, but the reason why we do this parallelogram method is because it has a lot to do with measurement. So, strictly speaking, so what happens when you now want to calculate, when you need to resolve something that you can't really draw on paper? Do you understand? So that's why the most famously used one is the what? Is the trigonometric method, and that one is pretty simple. So this is it. I have something like this, yeah, okay, and then as we've said, this guy is, let's just say x, right? So now I can turn this to a right angle triangle just by doing this. Permits my drawing, might not be perfect, but yeah. So I have, I can turn it to a triangle by doing this. So now, as you can see, it makes an angle here. There's an angle here. And now, following trigonometry, for laws of trigonometry, if you wanted to find the what's it called, the value of this guy, yeah. So remember, we have we have sokatua, so we have ka, and we have soa. And then remember, this is opposite of hypotenuse, adjacent of hypotenuse, then opposite over adjacent. So now, with reference to this angle, yeah, with reference to this angle, what I have is, if I have this over this, it reminds me of cosine, because this is my opposite. It reminds me of sine. Sorry, this is my opposite, right? We're to label this. This is my opposite. This is my adjacent, and this is my hypotenuse. Okay. So now, having said that, now because this angle is facing here, if I have something like this, opposite over hypotenuse, it reminds us of what? Of sine, right? So now, if I name this angle theta, okay, so I'm now saying that what? Sine theta is equals to what? So let's just write opposites. Or, okay, so instead of making it opposite, I'm just going to call it the vertical component. So let's just put VC, vertical component. So it's same as what? VC all over X. So I remember the person we're trying to find is what? Is this VC. So I'm just going to simply do is just what? Do VC, if you cross multiply, VC is equals to what? X sine theta. So if you want to find the vertical component of a vector, what you just simply do is you multiply the magnitude by the sine of the angle to which the vector was tilted, or which the vector deviated with, or is tilted. So if this angle was 30, for example, what you have here will be what? Sine 30. And if this x was 5, so what you have here will be 5 sine 30. So that's how you find the vertical component of, this is how you find the vertical component of your vector. Now, to find the horizontal component, so if I were to do, if you look at this guy here, it means what? Adjacent over what? Over hypotenuse. So what I'm saying here is what? Cos theta, is equal to adjacent over hypotenuse. I'm adjacent here, so I'm just going to name this one the horizontal component. Okay, so what I have here is the horizontal component divided by what? By what? By x. So if I cross multiply, because I'm trying to find the horizontal component, what I'm going to end up having is what? is equal to what? X cos theta. X cos theta. So that is how you resolve a vector into what is vertical and horizontal components. It's just as simple as that. So always remember this formula, it will help you. So this is how you resolve this is the vertical, and this is what the horizontal. Sorry, this is the vertical, sorry, and this is the horizontal. So if you want to find the vertical component, you multiply by sin theta. If you want to find the horizontal component, you multiply by cos theta. And then if you cannot remember, just simply remember this triangle. Do you understand? Remember that it makes an angle here with what? With the horizontal component, and then bring in your trigonometry. Opposite of hypotenuse, adjacent of hypotenuse, and then do your multiplication, and then you have your answer. So that's just basically how you resolve with that's basically how you resolve vectors. Basically how you resolve vectors. Very simple stuff. Okay. So yeah, let's move on. Okay. Yeah. Okay, so you have our formulas here where the horizontal component just is force. So F, we're looking at F, so we assume that the vector is F. So the vertical component of F is F times sin theta, and then the horizontal component of F is F times cos theta. Okay, so now addition of vectors, this is where it gets pretty tricky. So now when you are adding vectors, it's not really straightforward, right? When adding vectors, not really straightforward in the sense that because they have magnitude and direction, you have to be able to add in such a way that the answer you get has to be in what? Magnitude and what? And direction. Let me give you an example. So in scalar quantities, when you just add the magnitude, so the distance from point A to point B is 5 meters, and then from point B to point C is 7 meters. So that means the distance from point A to point C is just what? 5 plus 7, which is what? 12 meters. Very simple. But when you are now talking of vectors, now because there's this component of direction in them, that's what makes the whole thing. That's what makes it tricky. So it's not as straightforward as it would be. So what we do is, what we do is we find the resultant of the vector. So look at this example. So we have two types. We have adding perpendicular vectors and adding non-perpendicular vectors. So perpendicular, obviously perpendicularity means two lines meet at 90 degrees. So when you have vectors that are just straightforward, so they're not theta at an angle, they're just at 90 degrees. So looking at this example, I have this vector plus this vector plus this vector. So this is going northward, this is going northwards, right? And this is going eastwards, and then this guy is going northwards. So if you look at this diagram here, so it goes northwards first, then it goes 6 kilometers eastwards. Then it now goes 2 kilometers northwards again. So now, if I were to resolve this, if I were to add them, so obviously, because these two are going in the same direction, so that's not our vector. So because they are going at the same direction, because the vectors are going at the same direction, I can have 6 plus 2 here. I have 8. So adding this vector 6 plus 2 just gives me 8. Okay, then now I cannot just add this vector to this vector because they are not in the same direction. So there's one thing to note here. If they are in the same direction, just simply add them. Do you understand? If they are in the same direction, you just simply add them. So that's what we did here. Because this guy is going northwards and this guy is going northwards. And because they are in the same direction, you just simply add the two of them together. So this gives you 8 kilometers. But if they are not in the same direction, So that's when we now start to look at whether they are perpendicular to each other or not. So now, if they are perpendicular, yeah, so this is what we will have. So if they are perpendicular, what it means is you are finding the resultant of the two vectors. So that's what it means to add those two vectors. Remember, if you are moving in the same direction, you just simply add. But once the direction differs, yeah, once the direction differs, then you have to find the resultant. So as you can see from this diagram, this is the resultant because this is where you end up in the end. Do you understand? So because the sum is just trying to figure out what the what's it called? We are just trying to find the total of these vectors. So just need to find from here to here and at what angle. So the steps for perpendicular vector says that you use Pythagoras theorem to find the resultant vector, and then you use the tangent formula to find the angle. And remember, tangent is what? Opposite over adjacent. So you're going to do this over this, this over this to get your answer. So that's how I work over look at vectors. So we'll solve a couple of these questions at the end. So when we start solving examples, then I'll come back to show so that you can understand what is going on here. So yeah, so let's just go through the slide. So then I'll go to the app and then we'll start solving examples. So now the parallelogram method. So now when vectors are not perpendicular, so what do we do when vectors are not perpendicular? Very simple. So what we do is this. Because they are tilted at an angle and the angle is not 90 degrees. So what we're going to do is we're going to mimic a parallelogram, right? We're going to mimic a parallelogram. So you have this and you have this. As you can see here, this is a vector and this is a vector. So what we do is we try and what you do is you imagine that this and this, they are one half of a parallelogram, right? So you join this, so you extend it, so you're sort of completing what? The parallelogram. So this line here is the same thing as this line here, and then this line here is the same thing as this line here. So it's as straightforward as that. So now, once you have done the once you have completed the parallelogram, so how do you now find the resultant? So remember the cosine rule. So because what you have done here is you have completed a sort of what is it called? So this is this and this is like a triangle, and this and this is like a triangle. So because we're finding the resultant, so we can either treat the upper triangle or the lower triangle. Now remember cosine rule. So cosine rule, remember cosine rule happens when, okay, I know two sides and I know one angle. So that's what is happening here. As you can see from the formula here, you have what? A squared plus B squared. So you have A squared plus B squared times 2AB cos theta or cos P, because P is the angle between them. So we just use cosine rule to find the resultant. So when we get to the app, we're going to solve my examples on this. Okay, so yes, I think we've come to the end of vectors. So I think the next step for us is just to start solving questions. The next step for us is to start solving questions. So what I'm just going to quickly do is open the EdSofta app. Yeah, I'm going to open the EdSofta so you can have a sneak peek as to how it looks like. So okay. Okay, so this is the EdSofta UTME app. As you can see, it's a very beautiful app that we have right here. Lots of features, but the one we're concerned with right now is what? Practice exam. Yeah, so okay, so we don't really want timer, we just want to practice And then the wonderful thing that we have done here at EdSofta is that you can practice by topic. You can practice by topic. So now I can just scroll down to physics, right? So this is physics, yeah? And then scalars and vectors, yes. So I'm just going to deselect everything. Scalars and vectors, yeah. I can just select that, okay, I want to just practice or work on scalars and vectors. Do you understand? So gives us that sense of efficiency instead of having to wade through past questions, trying to find questions on a particular topic that we think might need work on. EdSofta just makes that easy for you. So scalars and vectors, and select the number of questions that I want to do. So it happens that we only have 10 questions on the subject. So voila. Okay, so now the first question. The figure below shows two velocities v1 and v2. Which of the following diagrams correctly represents the vector difference? W equals to what? V1 minus V2. Okay, so now remember, what we are trying to do here is now a diagram, right? So this is a vector, this is the direction it is going in, and this is another vector, this is the direction that it is going in. So now, how can we create a diagram that properly represents this, such that subtracting V1 from V2 gives me gives me W. How can I do a diagram that does that? Now it's pretty simple. So now V1 is going in this direction, right? This direction. So we leave that as that. But now there's something about V2, right? V2, we have minus here. So by putting minus, was sort of saying that we are going for the inverse. So that means if it was going this way, right, that means it should be going the other way around because of the minus. Do you understand? So it's going this way, right? So now because of the minus, it's going to go the other way around. So that means I am looking for something that so sorry, let me just quickly open my board. Let me just quickly open my board. Okay, so I'm looking for something. So let's just get rid of all this. So let me just use this section. So I'm looking, so it goes, the first one goes like this, yeah, V1, and then the other goes like this, V2. So now, minus V2 will look like this. So it's going the opposite direction. Do you understand? It will go in the opposite direction of where V2 was actually pointing. So this is what minus V2 would actually look like. Do you understand? Okay, so now, if I now join these things together, so V1 is going like this, and then V2 is going like this. So if I were to find the resultant, okay, oh sorry, no, this is not how I would draw it. So V1 is going like this, and then okay, so V2 is going like this. So that means this is my resultant here. This is my resultant here. Pardon my drawing. This is my resultant here. So, and then because I'm finding resultants from V1 to V2, so my vector 2 would go in this, sorry, let me just do this, okay? So I have V1 going in this direction, V2 going in this direction. So my V1, my W, the resultant would be like this, going in this direction. Does that make sense? So that's just the simple thing. So it just goes in that direction, and we have our answer. Okay, so oh sorry about that. I'm supposed to I don't know. Can you see my screen? For me, let me just fix that now. Share screen. Okay. Oh, sorry. Wow. We have okay. Hopefully, we find the question. Oh, okay. This is the question. Okay. So I'm looking for something like that goes this way, and V2 should be going away from V1. So I have V1, then my V2 should be okay. So this is my answer. V1 is going this way, V2 is going that way, and then my resultant is, yeah. So that's my answer. Okay, so now next, it says the component of vector x along the direction of vector y is 0 when, now this is pretty simple. So now the only reason, so the component of vector x along the direction of vector y is 0 when, now the only reason why vector x would, the component of vector x would be 0 along vector y's position is the fact that that means it does not have a component at that place at all. It does not have a component at that section. So that means I have two vectors, right? I have two vectors. So they are saying if I resolve, so the vector has two components. So if I resolve vector x in the direction of vector y, I get what? 0. And the only time when you try and resolve and you get 0 is when so that means it's when it is perpendicular. So when they are perpendicular to each other, then that means, so if you have like this, so you have vector x like this and vector y like this. So vector x is maximum here, vector x does not exist on this plane. So vector y exists here, but vector x does not, vector y does not exist here. So the answer here would be what? X is perpendicular to y. Okay. Now look at this. It says if the angle between two vectors P and Q is 0 degrees, the vectors are said to, this one is actually pretty straightforward. If vectors are perpendicular, that means they are 90 degrees. So if there's no angle between them, that means the angles, the vectors don't meet. And if the vectors don't meet, what that just means is that they are parallel. Do you understand? They are parallel. That means the two vectors are parallel. Oh, okay. Sorry, I was just informed that you guys can't see my screen. Okay. Sorry about that. Let me fix that. Okay, so I think I fixed that now. Okay, yeah, fix that now. Okay, so start tests. Okay. Wow, I don't think you guys can't see. Wow, you guys can't see my screen. For some reasons, I don't know why the screen is not showing. I think is, oh, okay. Um, so sorry about that. The screen is not. So let me see if I can work on that. Oh, okay. So yes, I think I fixed it. Yeah, so sorry about that. I think I fixed it. Okay, so moving on. The figure, so I think I've answered this while you guys were not around. Okay, yes. So I've answered this when you guys are not around. I remember the same. So ideally, so this one is just very straightforward. V1 is going in this direction and V2 is going in this direction, right? So this makes it. So, but now, if you were adding it, right? If you were adding it, what will happen is that the resultant would be from what? From V1 to V2. Yeah, the resultant will be from what? From V1 to V2. But now, because you are subtracting, right? So you are going to, what is going to happen is you're going to have the inverse. You're going to have the what? The inverse. So this would be the appropriate diagram for it. Okay. Now the next question. To answer this earlier before, say the component of vector x along the direction of vector y is 0 when, so the only reason why it can be 0 is when x and y are perpendicular. When they are perpendicular. So that means x only has one component and y only has only one component. So x has, let's just assume, the vertical component and y has the horizontal component. So so x does not have an horizontal component and y does not have a vertical component. So that means along each other's direction, they would be what? 0, because they don't actually have any components. Those respective components. Okay, so if the angle between two vectors P and Q is 0 degrees, what that just simply means is, so normal geometry even solves this, because when two lines, if there are no angles between two lines, that means those two lines never meet. And if they don't meet, the only obvious reason is because they are parallel. Parallel lines never meet. So the answer here will be what? Parallel. Okay, so now it's very straightforward. Which of the quantities listed above are vectors? Okay, which of the following listed above are vectors? So we have electric potential, we have torque, we have kinetic energy, and we have momentum. So torque first has direction, because its torque is just force, and it's force you apply at a given direction. So that's just torque. So that means 2 would obviously have to be my answer. Looking at 3, kinetic energy. Energy does not really have direction. Energy is just energy. There's no direction. You don't have joules in a particular direction. So that means 3 is out. So I've successfully eliminated 3. So that means my answer can never have 3. So C and D, they are out. So now we have to analyze electric potential and momentum. Okay, so momentum is a vector. Yes, momentum is a vector. Electric potential is not a vector, which we'll get to as we move on. Electric potential is not really a vector. So I would go for what? Momentum and torque. So that's what 2 and 4. Okay. Resultant vector. So this is pretty simple. We're going to use the technique. Well, to find the resultant, we're going to use the word Pythagoras technique. What is Pythagoras technique? And then, because we're writing JAMB, right? There's this thing called Pythagorean triples. Pythagorean triples, where a group of numbers, form the opposite adjacent and the hypotenuse. So let me give you an example. For example, I can have something like this. 3, 4, 5. They are Pythagorean triples. So 5 is the horizontal, and 5 has to be the hypotenuse. Then 3 and 4 interchangeably can either be the opposite or adjacent. So that's an example of Pythagorean, and it goes to prove. If I find the hypotenuse using 3 and 4 as my adjacent and opposite, 3 squared is what? 9. 4 squared is what? 16. So 16 plus 9 gives me what? 25. And square root of 25 is what? 5. So you do not even need to jot anything down in this question exactly. Because JAMB just wants to know how smart you are. So, and then this question does not really need to jot anything. So what you just need to understand is, okay, 6 and 8. So the Pythagorean triple for this is what? 6, 8, and 10. That's what practice does too. So the reason why I can identify this Pythagorean triple is what is practice. 6, 8, and 10, and I can prove it. So obviously we're finding the resultant, which would be from here to here, right? And that forms our hypotenuse. And fortunately, they are perpendicular. Okay, so now because they are perpendicular, I have what 6 Newton northwards and 8 Newton eastwards. Okay, so using Pythagoras theorem simply, it becomes 6 squared plus what? 8 squared. And 6 squared, as we know, it is what? 36. 8 squared is what? 64. 64 plus 36. And then even, okay, we have one handy feature here, calculator. So 64 plus 36, so that you can be sure. So 100. And then we all know that the square root of 100 is what? Is 10. So that answers the question. So let's just put the calculator somewhere here. So that answers the question. Okay. So which of the following is a scalar quantity? Tension, weight, impulse, mass. Tension, weight, impulse, and mass. Impulse is momentum in the given direction. So impulse cannot be a scalar quantity. Mass, I would say, is a scalar quantity because there's no direction for mass. Weight is direction, tension is direction, because all these are forces, and forces is what? Is a vector quantity. Forces, all tension, weight, they are forces. And force is a vector quantity. So mass will be my go-to for a scalar quantity. So the pair of physical quantities that are scalar only are volume and area. You don't even need to, because displacement is not displacement is a vector quantity, momentum is a vector quantity, impulse is a vector quantity, time is not a vector quantity, time is a scalar quantity. So they are looking for the pair that is just scalar. So volume and area satisfies that condition. And then the pair of physical quantities consisting of vectors only are, so you cannot say acceleration and speed because speed is a scalar quantity. Displacement and torque, yeah, I'll go displacement and torque. But let's just go through the other options. Velocity and distance. Distance, as we know, is not a what? A vector quantity because it does not have direction. And the momentum is a vector quantity, yes, but power is not a vector quantity. Power is just work done over time taken. You don't need to know what direction the power is being applied to. You don't need to know that information. So our power cannot even provide us with that information. So displacement and torque are both vector quantities. Okay, which of the following is a vector quantity? We have temperature gradient, mass, work, and time. So time is out, mass is out. So we have to choose between temperature gradient and work. So the first thing you need to do is work is what? Force times distance, and work can also be what? Force times displacement. Okay, so that means vector work can be a vector quantity because force you can have force times displacement. So I apply work in a given direction. Yeah, but temperature gradient is just the difference in temperature in two places. So it does not really give us the direction as to where the temperature is flowing or not. It does not give us there's no direction quantity or there's no direction component in the temperature gradient. Okay, so which of the following consists entirely of vector quantities? Okay, so we're going to eliminate. So now because mass is here, that's nullified option A because mass is a scalar quantity. Because power is here, it has nullified option B because power is what? A scalar quantity. Work, pressure, and moment. Yeah, pressure is a scalar quantity. And then we have velocity, magnetic flux, and reaction. I would go with what? Velocity, magnetic flux, and reaction. Okay, so now, and with that, we have come to the end of vectors. Yeah, it's a pretty short topic. Yeah, it doesn't really what's it called? It's not really very strong Sorry, it is an important topic though, but it's not really a very broad topic. Okay, so does anybody have any question on vectors? Do I need to explain anything or expatiate further or something? If you have any questions, you can just comment or say something. So questions, anybody? Does anybody have questions? Nobody. Nobody has questions. Okay, so well, if you don't, well, we still have a couple of more classes to go. So maybe you would or you could ask your questions then. So, but for now, we're just going to quickly take a break. And when we come back, we are going to start with electricity. Okay, yeah, electricity. So, yeah, thank you very much. And I will see you in the next 30 to 45 minutes. Yeah, 30 to 45 minutes. Okay, thank you very much.